by a driver. Going 70 miles an hour into a barrier is not the safest thing to be doing. Luckily, there's quite a few measures put in place to keep our driver person-shaped. The main way to prevent pancakeification of our driver is linked to the idea of momentum. It is the hot commodity for all objects travelling at a speed. It is related to the object's inertia, which is a measure of how much something wants to not change its motion. Heavier objects have a higher inertia, as it takes more force to get the mass to change its movement. Similar sized masses can also have different momentums. If you have two controllers, and one is flying at a TV at 20 meters per second, and the other is stationary on your bed, the projectile controller will have more momentum, as the kinetic energy is also important. All this can be summarised in the equation momentum equals mass times velocity. This isn't the final form of our equation, but it will help us for now. As you can see, a higher mass will increase momentum, and so will a higher velocity. For our driver travelling in a 1.5 ton hunk of metal, travelling at 33 meters per second, it spells a bad time. Luckily, designers have been designing cars to be as un-death machiney as possible for a while now. Their first idea was to make cars as rigid as possible. This way the car would stop in as short a time as possible, and it would also take the brunt of the collision without being too damaged. However, if these designers had scrolled down a little further on the Wikipedia page, they would have seen that momentum too had dropped. Instead of writing it as momentum equals mass times velocity, it would be more accurate to be written as the change in force times time equals the change in mass times velocity. The patch notes draw attention to the introduction of impulse instead of momentum. Rearrange the equation a little, we can see that force on the driver is related to the time to change momentum. A longer time of collision will lead to a smaller force on the driver, and vice versa. So our designers had unknowingly created a death machine, the very thing they swore to destroy. It turns out that the best way to increase the time of collision, and therefore reduce the force the driver experiences, is to destroy as much of the car as possible. Most cars nowadays have crumple zones in the bumpers and boot. These are dead spaces which only function as to self-destruct the moment the car collides with something. These are very effective in getting in the way of the car's chassis on the warpath to the barrier. Even a fraction of a second increase of the collision time caused by these measures increases the survivability of collisions dramatically. This can be seen here. The mangled mass of metal has increased the impact time of the vehicle enough so that the box the driver sits in is relatively undamaged. However, this measure only slows the car's collision with the barrier. Without any internal protection, the driver will continue into the dashboard at 70 miles an hour due to him having inertia. So how are we going to stop him from becoming mush? What if we make him part of the car? Seatbelts are relatively new gadgets that get as close as a human steel alloy as comfortably possible. These straps anchor the driver and any passengers to the vehicle to stop them becoming airborne in collisions. They also help increase the collision time as the straps have some give, also preventing a rerun of the Final Destination movie. The only issue with seatbelts is that they don't stop the appendages from impacting the car frame. This is a particular issue for the head, as it is very susceptible to this. To stop any impromptu brain smoothies, designers installed measures that have the same tactic my cat uses when I'm trying to do something. Oh, come on, move!
Getting in the way. They call them airbags and put them into the dashboard and walls. These stay hidden until an impact is detected, where they inflate to cover all hard surfaces. This cushions the head, increasing the collision time to reduce the force on the driver's head. With use of all of these measures in conjunction, designers have managed to reduce the danger of collisions majorly. Despite them wanting to think all the thinking was theirs, most of the current measures are based off the work of Newton back 3 centuries ago. Take that, engineers.